Good afternoon and welcome to this lecture on the framing of quantum mechanics. It's been a little over 100 years now since we first started out with quantum mechanics. That was Planck and Bohr and Einstein, de Broglie, Pauli, Heisenberg, and it's been just under 100 years since Schrödinger gave us his wonderful equation. After that we had a list of greats: Dirac, Wheeler, Bell, Feynman, Bohm, Hawking, and they all made their contributions and they all said the same thing. We don't really understand quantum mechanics. The maths all works out, the experiments all work out, the theory seems consistent, but what it all means in terms of explaining the world in day-to-day sort of language, we just never seem to be able to get any traction. Every so often, perhaps once every generation, we gear up for another try. We say, all right everyone, eat lots of fish, get lots of sleep, we're going to try and understand quantum mechanics again. Everyone ready? Concentrate. 3, 2, 1. No. We still don't understand it. I feel I might have spoiled my own punchline here a bit, because I'm sure everyone can see it coming a mile away. But if you've got the brightest brains in the world trying to understand something for 100 years and they still can't understand it, maybe we're trying to understand it the wrong way. So what is the problem? What is preventing us from understanding? What tenet or principle or dogma is preventing us from seeing things clearly? Well, it must be something pretty fundamental, I think we can say, because quantum mechanics is pretty fundamental and our perplexity is thorough. And it must be something that's been around for more than 100 years, because we've been confused by quantum mechanics ever since we first started out in them. So what fundamental principle has been around for more than 100 years that might be getting in our way? Again, I feel that everyone must be able to see it coming. What else can it be besides the reductionist paradigm itself? The reductionist paradigm of a mechanical universe, the framework of modern science in the West for the last 400 years. Well, that would explain why it's been so difficult to step out of the box and see things from a different perspective, because the reductionist paradigm is almost synonymous with science. How can you step outside of that and still be within science? And yet we know, or could have known, that the reductionist paradigm and quantum mechanics are irreconcilable, because the reductionist paradigm is deterministic in nature, and one of the earliest and most important lessons of quantum mechanics is that the universe is not deterministic. Indeterminism is an underlying feature. So really we've known all along, or could have known, that if quantum mechanics is right, then the reductionist paradigm must be wrong, and we will have to figure out another way of looking at the world. Well, what other options do we have? Well, there's the holistic paradigm, which is sort of the opposite of the reductionist paradigm, where instead of trying to understand things in terms of their constituent parts, we try and understand how those parts come together as a whole. And no sooner do we start thinking about quantum mechanics in these sorts of terms than some things immediately fall into place. For example, quantum entanglement, or non-locality, is a holistic phenomenon. It's not so much that there is communication between one photon and then another in Alain Aspect's experiment of 1982. It's that the whole system is resolved at once, simultaneously, even though the parts might be separated by light years. We cannot actually engage with only a part of the system. We can only engage with the system as a whole. So quantum entanglement is holistic in nature, which gives us the idea that we might be pointing in the right direction. Other quantum phenomena, such as indeterminism and the electron cloud, are also candidates for a holistic explanation. The main problem is that the holistic paradigm is so counter to, so foreign, so different from, so opposite to, in fact, the reductionist paradigm that we're all used to and comfortable with, that inevitably most people will reject the holistic paradigm instantly, to saying, no way, that can't be right. That is completely opposite to everything I've ever learned. Now we know really that it's going to take something like that, because everything we've ever learned has not got us to the point of understanding quantum mechanics. Perhaps what we really need is another one of these concerted, once every generation efforts. Everyone get ready, eat lots of fish, get lots of sleep. We're going to try and understand the holistic paradigm. I guess that will have to be the next lecture. Hopefully see you there. Thank you.